Welcome to our video today, where we're going to dive into a fascinating topic in machine learning, random forest. Specifically, we'll be exploring whether the prediction made by a random forest model is simply the average of its leaf nodes. If you're interested in understanding how these powerful models work under the hood, then this video is for you. Random forests are one of the most popular and widely used machine learning algorithms due to their simplicity, flexibility, and impressive performance on many tasks. However, despite their popularity, there's still a lot of confusion around how they actually make predictions. In this video, we'll break down the process step by step, using analogies and examples to help illustrate the key concept. So, let's start with the basics. A random forest is essentially an ensemble learning method that combines multiple decision trees to produce a more accurate prediction. Each tree in the forest is trained on a random subset of features and samples from the training data, which helps to reduce overfitting and improve generalization. Now, when it comes to making predictions, each decision tree in the forest will output a prediction for a given input sample. But how do these individual predictions get combined to produce the final output of the random forest model? The key insight here is that the prediction made by a random forest is not simply the average of its leaf nodes. To understand why, let's consider an analogy. Imagine you're trying to predict the price of a house based on its features, such as the number of bedrooms and square footage. In this case, each decision tree in the forest would be like a different real estate agent who specializes in a particular neighborhood. Each agent, or tree, would make a prediction about the house price based on their expertise, but these predictions might not all agree with each other. If we simply took the average of these predictions, we'd essentially be averaging apples and oranges. The agents might have used different criteria to make their predictions, such as the number of bedrooms versus the proximity to schools. By taking a simple average, we'd lose this important contextual information. But instead, random forests use a more sophisticated approach called voting. In the case of classification problems, each tree in the forest outputs a class label, and the final prediction is determined by a majority vote among all trees. For regression problems, like our house price example, the final prediction is typically taken as the average of the predictions made by all trees, but with an important twist. The averaging process takes into account the importance or weight assigned to each tree's prediction. This weighting scheme allows the model to focus more on the predictions made by the most accurate trees and less on those that are less reliable. So, what should you take away from this video? Here are the key points. Random forests make predictions by combining the outputs of multiple decision trees. The prediction is not simply the average of its leaf nodes. Instead, random forests use voting or weighted averaging to combine the predictions made by all trees. That's it for today's video. We hope you now have a better understanding of how random forests make predictions and why they're such powerful models. If you have any questions or need further clarification on any of the points we discussed, please don't hesitate to ask in the comments below. If you liked this video, be sure to like it and subscribe to our channel for more machine learning content. We'll catch you in the next one.